All right, taking a look. No calculator problem. The average value of the function f of x equals x minus 1 squared on the interval from 1 to 5 is, well, let's take a look. What is the value? So the value of the function is, putting 1 in, putting 2 in, putting 3 in. Those are the values of the function. So what's the average value of the function? Let's take a look at the graph. So right one parabola. And we're going from 1 to 5. So these are the values. All those y values are the values. Now, what would you say the average value would be? Well, we could add up all the values and divide by how many. So let's do that. How do we add up all the values? We take the integral from 1 to 5 of x minus 1 squared dx. So our entire power rule is just x minus 1 cubed over 3 from 1 to 5. So let's take a look. If I put the 5 in, I get 4 cubed, which would be 64 thirds, minus 0 in that case. So it's 64 thirds is the total value. So then I need to do the 1/4 of that. So 1/4 of 64 would be 16 thirds, I believe. And there it is. So a common mistake on this one, real quick, would be for someone to take the value at 1, which is 0, and the value at 5, which is 16, and just do 16 over 4. And actually, they didn't even give that as a value. I would think that would be a very good, wrong answer. You can see this wrong answer would be forgetting to divide by the 4. What are the other ones? This one might be adding them. This one is just 22. Yeah. Don't do that one. Do the whole average value. This one looks like a chapter 3 or 4 test question. Which of the following integrals correctly corresponds to the area of the shaded region in the figure above? So we've got the function y equals 1 minus plus x squared. We've got the function y equals 5. And it looks like this is the area we're looking at. And I think I kind of drew that right too, really. The words we say in class are top minus bottom. So let's take a look. The top curve is 5. The bottom curve is actually the 1 minus x squared. And where would I be going from? From 1 to 2. So 5 minus 1 is 4 minus x squared from 1 to 2. Let's take a look. Well, there's really only one that does that, isn't there? 4 minus x squared. Now let's take a look at some of the mistakes. They went from 1 to 5 on 3 of these. What were they trying to get you to do? Looks like they were trying to get us to go maybe this way. Well, I guess that'd be from 0 to 5. Yeah, none of those would really work. I guess you did have another 4 minus x squared, but that 1 to 5 is definitely throwing me off. Yeah, all good. All right, let's take a look. If f of x equals secant x plus cosecant x, then the derivative is, now this one could be calculator, no calculator, it really wouldn't matter. We've got to know our inverse trig or reciprocal trig derivatives. So real quick, let's go over how we find the derivative if we forget. If I have secant, it's 1 over cosine. And then we derived that in class. We kind of proved the derivative would be bottom or low d high minus high d low over low squared. So we ended up with sine x over cosine x times cosine x, and that's kind of how we wrote it, which is secant, which is tangent. So usually we write that as secant times tangent. And we discussed in class that if we know what the secant derivative is, the cosecant has just the cos with a negative. So the derivative of secant is secant tangent. The derivative of cosecant is cosecant cotangent with the negative. So this one's got the negative. So it's only going to be e. Definitely could see how you might make a mistake with the squares. Maybe even thinking that the derivatives were the same, so, or just with that minus sign you subtract them. Like, probably a very good problem there. All right, last one then. If f of x equals 5 over x squared plus 1 and g of x equals 3x, then g of f of 2 is, well, f of 2 is 5 over 2 squared plus 1 equals 1. So g of 1 is 3 times 1 is 3. Good. Pretty basic, nothing too challenging on this one. We'll keep working.